1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 1, 2, 1, 2. Mic check. Mic check. Mic check. Let's see. Mic check is good. Mic looks good. Mic looks heavy. Mic looks 97% input. Okay, I hope it will stay like this. I hope it doesn't change. Elmano, what's up, Elmano? What's going on? Why don't you join us? Join us, Palers. Palers, join us. Oh, two people watching. Wow, two people watching. That is such honor. Such honor. Great. I'm waiting for you to join. Do I know Andrew? Of course I know Andrew. Andrew is my favorite guest. I'm always talking to him. I just had a conversation with him. He just took his IQ test and he got above 130, so we know he's a genius. There you go. Now you know. All right. Let's continue. So we are doing. He is a fictional debater. He's a good debater. I don't know what you mean by fictional debater, but he's a very good debater, very interesting debater. Let's see, is the audio still good? Yeah, audio is good. All right. So we were in the process of listening to this guy, but we're also waiting for Elmano to join. That should be interesting. So, Elmano, let me know if you're able to join. Let's continue. Oh, Andrew, are you Elmano? There's an Elmano that asked me, do I know Andrew? So you are Elmano. I'm on YouTube, on YouTube, on my YouTube. No, no, I'm saying somebody on YouTube asked me, do I know Andrew? His name is Elmano. What is a fiction? What is a fiction? Yeah.
That Saitama or Superman is stronger than, let's say, Spider-Man, and
Oh,
debate your hypothesis, basically.
oh, I see. That's fictional debater. That's interesting.
Yeah, I would be listening to you, right?
You want to listen? Okay, but I don't know if you'd be able to hear me. I'm not going to be on Discord. Will you hear? Yeah, I think you'll hear me on Discord. Yeah,
Yeah, I can be watching your live too.
yeah,
Right.
yeah, yeah. Okay, so I'm gonna go listen to this guy. All right, let's see what he says.
Right, so Newtonian physics, and you don't get that. That was a big problem. So people tried to fix it up by doing different models of ether, but none of it worked. And nobody knew why light is behaving in this peculiar fashion. That is very contrary to what we believe. In fact, that's in violent opposition to this law here. If this V were not a bullet but a light beam, suppose for me traveling at a speed c.
Yeah, this doesn't make any sense because he was talking about trains and now he's talking about waves. So this discussion is a complete waste of time. If he would be discussing waves, then the theory of relativity would disappear into wave mechanics. So I don't know why they teach the theory of relativity with trains. It doesn't make any sense. They teach it with trains, but they're implying that light is a wave because light is always a constant speed for all moving observers. That is not basically, that is what a wave is. If your clock is based on the waves that you are measuring. So the theory of special relativity is just a complete misunderstanding. That's all it is. It's just wave mechanics misunderstood. It's like convoluted inside this discussion, this complete waste of time discussion is wave mechanics. All you need to understand is wave mechanics, not even a wave theory, just wave mechanics. It's, there is no special relativity, there's just wave mechanics. Congratulations.
And you're traveling at the right speed you should get C minus u. That's the inevitable consequence of Newtonian physics.
No, nothing to do with Newtonian mechanics. This has to do with waves. And I don't know how you, like, as I said, when I first watched it, I kept yelling at the screen, but there's no way to write comments. I kept yelling, like, but what about the waves? I mean, if you just think of just waves, everything should work out. I didn't work it out. I mean, I didn't know how to do that. I didn't think that it would make, like, it's not my job, it's his job. I thought, okay, maybe they know better, maybe they know something I don't know. But if you just consider just the pure wave mechanics, my intuition was that this entire lecture is a complete waste of time. Well, now I know it's a complete waste of time. All of special relativity is complete nonsense. Einstein's paper on special relativity is complete nonsense. It's just wave mechanics.
And you don't get that.
So that's basically the paper that I want to write. And that's what happens when you just, well, I'm just going to explain the special relativity of the rubber ducky. That's going to be the paper. Rubber ducky special relativity. It's going to be a joke. People will read it and they will say, "Oh, so special relativity is just wave mechanics." So we wasted 100 years believing in nonsense.
Was a big problem.
Well, not nonsense. The main understanding of Einstein is that our brains are waves in the ether. And he implicitly figured it out. Implicitly. Well, now we know that is the fact. So retroactively, with hindsight, special relativity is just wave mechanics. You're welcome.
So people tried to fix it up by doing different models of ether, but none of which worked. And nobody knew why light is behaving in this peculiar fashion. So that's when Einstein came and said, I know why light is behaving in this peculiar fashion.
No, he didn't. He did not. He just assumed.
Behaving in this way, because if it didn't behave in this way, the speed of light depended on how fast I'm moving, then when I wake up in this train...
That's not an explanation. Because if it didn't, then... No, you need a mechanical explanation. It's not an explanation. What you're saying is not an explanation. You can't say because if it didn't, it would create a paradox. That's not an explanation. That's ridiculous. That's not an explanation.
All I have to do is measure the speed of light. If originally I got some number, now I get a different number, the difference will give me the speed of the train. So it would have been possible to detect the velocity of the train without looking outside, just by doing an experiment with light.
So, what? That's not an explanation. It's like, you have to become my girlfriend. Why? Because if you didn't, then it would create a paradox. That's not an explanation why you need to become my girlfriend. You need to become my girlfriend because I'm a great boyfriend. I'll make you dinner. I'll do things for you. I'll take care of you. We'll have a great life. That's an explanation. To tell me you need to become my boyfriend, my girlfriend, otherwise it will create a paradox. That's not an explanation. That's not a mechanical explanation. You could resolve a paradox in other ways. But to give a reason why it makes sense, that's mechanical. And Einstein never gave a mechanical explanation. He never gave an explanation. He postulated. Did you read his paper?
So even though mechanical laws involving F equals ma are the same, laws of electricity and magnetism would be such that somehow they will betray your velocity.
What do you mean they'll betray my velocity? What? So what? So what if they betray my velocity? I can figure out my velocity using an interferometer if it's accurate enough. So I can get my velocity. I don't need... That's not an explanation. It's not even true. Even what you're saying is not true. What are you talking about? How can you stand there, look people in the eyes, and lie to them? What are you talking about? Utter nonsense. Am I the only one? What? Yo, my Discord is tricks. Well, I don't see you, so why don't you? What do you mean your Discord? You need to join my. I gave you the link. Click on my Discord link and join my Discord server. Join my room. You have the link. Just click the link. Here's the link. Just click it. Click the link. Click. Click. Click the link. Everything will be well. Oh my God. Ah. So this is so ridiculous.
That would mean uniform velocity does make an observable change because it changes the velocity of light.
So what? So what if uniform velocity makes an observable change? So what? Who cares? It's visible. You can even use the compass if you really wanted to. I mean, you can do many measurements that are in the air, especially the interferometer. Especially the interferometer should give you, an understanding of your velocity. Unless, it should give you a velocity. You can infer somewhat. It gives you some information, but why is it important? Why is that relevant? So what if it betrays my velocity, my uniform velocity? So what? Hey, Senas, what's up?
Oh, what's up?
Hey, I'm still doing research the whole day. I'm still, I went through I'm digging up every possible thing. And I went through the...
Yeah, I saw it.
Oh, okay.
I saw some of your live streams.
And
I was just, I was just doing other stuff.
Okay, and I was speaking to University Existence.
Yeah, I saw that too. Not very interesting.
Right, but I proved to him, I proved it to him, and he didn't even accept it. He said, "Okay, send me the paper when you're done." It's so ridiculous.
Okay, I mean, he only has like one good point, which is like the ether. If you consider that it's tracking bodies, you have there would have to be a problem, like it would be able to have some resistance.
Yes. Yeah, that's a problem.
He's right about that, but that's it. But you have to understand that the ether, if you're going to consider the ether has to be the source of inertia. So bodies, when they are accelerated at a certain velocity, then they go in equilibrium with the ether.
Mm-hmm.
So
yeah, because the ether is the Higgs, so mass comes from the interaction with the ether. So
inertia. That's a more correct way of saying.
Mm-hmm. Okay. I mean, the same interaction, the same impact of the mass, that's the same interaction that creates gravity. That's why all bodies, that's how you get Galileo's equivalence principle, that all bodies accelerate towards the ground at equal rates regardless of their mass, including a mass that is infinitesimally small, gets close to zero, infinitely close to zero, which basically is light. So because the interaction with the field is the same as the interaction with the gravity, so it's the same it's an indication that it's the same interaction that gives you the inertia, gives you the mass of the inertia, it gives you the mass for the gravitational interaction. So it sounds like it's the same interaction. So the Higgs, and if it's the Higgs mechanism, which makes sense, then it's the very Higgs mechanism that drags the planet into the sun. But there is no one complains about friction, right? No one says the Higgs mechanism doesn't create friction. So the Higgs mechanism, the same way it doesn't create friction, there's no friction, it's not going to create friction. There's no loss of energy. It's a lossless interaction. There's no energy.
Yeah, I mean, if the ether goes against you at some point, it will come into equilibrium if you're moving in a certain direction. Just if you think about it, it's not that difficult to understand that.
Wait.
So
assuming the ether,
if you're moving at a certain velocity, you will get more ether in the opposite the direction that you're moving. If it's going against you, it will just move faster. Again, it'll just move faster against you. Like, you see what I'm saying or not?
No, I don't see.
Okay, let's
I mean,
go with like a whiteboard.
it's the Higgs mechanism, right? Are you assuming
Yeah.
that it's the Higgs mechanism?
I don't know much about the Higgs mechanism.
Oh, it's very simple.
What?
It's really great. The Higgs
A
mechanism.
whiteboard doesn't do anything. It's just
No,
like
but I think you
it's like
should.
super zoomed. Like, how do I unzoom my whiteboard?
You need to zoom out.
Yeah, but wait a minute. No, but it doesn't zoom out. Like, I'm
No,
trying.
you need to use your
Oh, it's
mouse.
zooming out. Yeah. Okay, so basically, if, okay.
I don't see your mouse.
So you don't see my mouse.
Well, try to. Are you?
Okay, now you do.
I created
Right?
I created a canvas for you with your name, Senes.
Oh, you created a one for me. Okay, so I wasn't on that one.
Okay, now I see you.
Okay, I have to zoom out this one. Okay, so now you see my mouse,
Yeah,
but
yeah.
I see yours.
Yeah. You don't see mine? Here's mine. Do you see mine? Do you see X? Do you see an X? Are you there?
Yeah, I'm in here.
Okay.
So, for example, if this is you,
Okay.
if something's going against you and it's accelerating towards you,
Mm-hmm.
and you move,
Mm-hmm.
and that's why you move a little bit. So, and the thing is attracted to you, it will move. It will move faster towards you.
Wait, what?
Yeah, if this is attracted to you,
What is it?
right?
What are you describing? Is it the ether?
Okay, if this is like the ether and this is attracted to
Is it a
you,
field? Wait, but
right?
define the ether. So it's a field, because the way I see the ether, it's a field of particles like any other. It's a field of particles interconnected
Yeah,
by spring.
you're saying that you are saying that it's attracted to you, right?
Oh,
Like it's coming.
it flows into you and it self-destructs on impact.
So you think it's soft spots on him?
Yeah.
So, and
Just like it comes out of nowhere. Just like
and in your view, that's why it's not like that's why it doesn't cause like any drag.
What?
I see. So in your view, that's why it doesn't cause any drag.
No, I didn't say that because when you're standing on Earth, it flows through you and it's dragging you into the Earth. That is gravity. It flows through you and it's dragging you into the Earth. The ether flows through you.
So it has to
Here's
flow.
the apple.
So why doesn't it get destroyed when it touches you? In that case,
when it hits the Earth, it self-destructs. When it hits a particle, it self-destructs. When it hits a neutron, it self-destructs. Otherwise, how could it forever flow? It needs to forever flow. So the dark energy.
It would get concentrated around the air.
It can't. It has to forever flow in. It's forever, for trillions and trillions and trillions of years. It has to flow. So in the interglobular space, it gets created, and that is the dark energy. And when it hits a particle, it destructs. It has a life cycle. It probably has a half-life. So it gets created in the interglobular space, and it flows into the galaxies. That's probably dark matter. Dark matter is just the flow. It speeds up as it flows into the galaxy, and it becomes heavier because of relativistic effect. We see it speeding up. Therefore, its mass is greater, even though we can't see it. But that's why the galaxies become heavier, and that's how you get dark matter. and in the interglobular space, it gets created and creates dark energy and creates the expansion of the universe in redshift. But when it hits any matter, it flows in. It flows into the galaxy and destructs. It floats into an electron, into a proton, into a neutron, and it self-destructs. So it has a life cycle.
Okay. So, but that you still have the same problem. Like when you're moving, it
Yes,
doesn't cause you any drag.
it flows through you right now. It's dragging you into the ground. It's dragging the apple into the ground.
Okay, but that is like it. Wait,
Let's create a new
but
page. Let me create a new
there's
page.
like it all over the place here.
Let me create a new page. This is going to be Senas 2.
No, this is okay.
No, there's no more room.
Uh,
Senas.
no, but I don't need more room.
Anyway, I created the new one. Come over to the new one. We're running
Okay.
out of space. We can't draw anymore. Anyway, the question is why is there no energy loss? It looks like it should create friction. It should heat me up, but it doesn't heat me up.
Yeah.
My temperature doesn't change. So I don't know how it does that. Oh, because I'm a wave. Sorry. Because I'm a wave. That's the proof. I'm waving through it. I'm waving. So here's the ground. Here is the ground. Here is the apple, and the ether flows in, but the apple is waves. There is no particle. So the apple waves. That's why there is no energy loss. It's just waving through. And that's why, okay, that's it. There's no energy loss. But why? But it does create a force. It does create a force.
I think this is different. I think the explanation has to be different.
Why? So what's the explanation?
Like the ether can't really drag, but it may be able to attract something. May be able to produce attractive forces.
No. I mean, I came to the ether theory I started from Newtonian. I started from a black hole. So you
Okay, but that's okay. You can
no.
the idea can still change.
You can't look here. Here's the evolution. So we know that F equals ma, and we know that F equals. This is. I'm sorry.
And I mean, okay, well, let's be specific about what M means here.
But
what M really is really representing
it
in
doesn't
the first
matter.
one is really no, it matters.
No, but this is
The first,
empirical.
what M is representing in the first one is inertia.
But this is empirical information. This is empirical.
Yes, it is empirical information.
What?
Yes, it is, but it's still good to understand what it's about, right?
That's fine, but you
don't. I mean, the first one.
But you don't have
really.
You don't have to understand it. All you have to admit.
But it's convenient.
Yeah, but you start.
I don't have anything against that, but
right,
it's still like it's still good to understand like what
fine,
what the mass is, and why a force causes an acceleration, and then as you stop producing the force, the thing just goes in the same speed. And why doesn't it why doesn't it just
fine? But
why does it work like that? Why it doesn't stop? Why? Yeah, it's if there is a medium, the medium then is not stopping it. So that's something that needs to be looked at. So the medium, in fact, has to be at equilibrium with a moving particle or with a moving object.
Anyway, look, we know this is empirically true, right?
Yeah.
This we know from the motion of planets. So Tycho Brahe wrote down the motion of the planets. Kepler summarized it in the equal area triangles over time, and Newton got the inverse square law from that. F equals ma is basically F equals mv. This is conservation of momentum. The force creates mv1 minus or mv1 minus mv0. Right, that's how you get F equals m delta v, which is v1 minus v0. That's F equals ma. So a force changes the velocity from velocity 0 to velocity 1, and that is acceleration.
Yeah. But if we have a medium,
divided by.
again,
Wait, divided. It's not just that. It's v1 divided by t1 minus t0. So it's delta v over delta t. I still don't know how Newton got this. Where did he get it from? How did he come up with this equation? But let's assume it's true. So if we respect F equals ma empirically and respect F equals gmm over r squared, then these two F's are the same. So ma equals gmm over r squared, and you can drop one m out. So this is the Earth. So the acceleration field, this is now the acceleration field. It's gm over r squared. It's a vector field equation. So the vector A field equation defined that for all x, for all t, is equal to gm over r squared r vector. So it's a vector field equation. And you can convert it into a velocity field equation, and you get the velocity. It's not so simple. You have to do some games with integration.
Yes, but this is besides the point.
No, but this is the acceleration of a test particle at any place. This is the acceleration of the very ether. This is the acceleration.
Okay, but the point was like, so the idea of ether drag. If there is drag in the ether, then it's like it wouldn't work very well like that. Like you have to think about it in
there's no drag,
way. Like,
but it's all waves. There's
like both have to be at rest with the ether, and the ether has to be at rest with bodies. And what changes that would be a force. Like, so the force causes acceleration. There is inertia, which is basically what tries to establish that the body doesn't want to move from a place of rest.
No. I would say that there is no particle. All particles are waves. Everything is waving through the ether.
I mean, everything is waving. That's okay to say, but things are waves cannot be. Really, that can't be true.
No, everything is
like waving. Wave is something that something does.
Everything is waving, and the interaction with the Higgs mechanism makes it wave back and forth and gives the illusion of mass. Because it
okay, that could be. So it would wave back and forth.
But there's no energy loss. This is the Higgs mechanism. Yeah. There's no energy loss while this is happening.
I see. That can work. So, okay, so when something is moving at a certain velocity,
now
what happens with this waving?
So this field is moving down.
No, but what? Yeah, okay, I see that. That's okay. I'm saying when something is moving just through the field, now independently of the movement of the field. Anyway, so something is moving in relation to the field.
There is a force. The problem is, why is there no force to stop the planet as it's moving?
Yeah, that's what I'm talking about.
There should be a force, not drag. There should be an interactive force. So so the ether, so the way I would say is because there's no tension. So there is, because this is not just motion. This is not just motion. This is low pressure and high pressure. Because
Mm, okay.
near the earth, near the sun, there is a vacuum. The sun is a vacuum pump. So it's low pressure. This means that the ether is under tension this way, where there is no tension this way. So as a fluid, there's a gradient. There's a gradient that is creating the force of gravity. There's no gradient this way. So maybe,
Yeah, the gradient is
so
there.
there's no drag that way.
But still, if it's some kind of fluid that it can't really be a fluid that drags things, that still doesn't work. It has to be a little bit different.
Well,
It has to
it's
float
not. It's not
things
a
and then
normal.
become at
It's
equilibrium with
it's
them.
not. It's not a normal fluid. These are the rules. As long as there is a gradient in the pressure of the fluid from high pressure to low pressure,
Oh, I see.
then you get the drag. But this way, there's no left to right. There's no gradient.
So you attract it towards low pressure,
I mean, it
so
flows.
you're repelled by the medium.
As a fluid, it flows from high pressure to low pressure. Low pressure is, for example, the earth. So it flows towards the, so the apple falls towards the earth because there's low pressure. There's a gradient. Because of the gradient, it goes down. This is, by the way, the same reason, like underwater, you have buoyancy. The buoyancy is created by the gradient of pressure. This gradient
Yeah, I know.
pressure
But
forces a net
for
force.
example, if you have like a drain or something like that, if you have a drain, the problem with the drain is that yes, the center of the drain has low pressure,
Yes.
but there's a zone before the drain is before you go into the center. There's a zone of high pressure. So it's not like exactly like that. It's more like there are zones of high and low pressure
I'm gonna create a
throughout
new page.
the entire thing.
Send us. I'm
Yeah,
gonna create
but
a
it
new
will
page.
be
Send
new
us to me.
page.
Anyway, let me. But this time we're gonna be use it more sparingly.
Uh,
Anyway,
whatever it is,
so but I think
anyway.
GR. All we're saying is GR. GR should explain it. We don't have to come up with an explanation.
It's not very different from GR in the end. Just that they want to insist that they can explain the universe without the media.
No,
So,
GR.
for example,
No,
if
no,
you
no.
have like a drain going here and and this is draining into here, at some point here you're going to have like an empty zone, right?
Yeah.
Yeah, but in this zone that's draining, it's actually rather high pressure.
Well, if you don't create the
Yeah,
whirlpool,
especially around the empty zone, there's actually rather high pressure.
right? But you don't want to. Yeah, simpler to just have a pool, and here you have, here it's empty. I mean, here you're emptying
Yeah,
the pool. So
yeah, you're going to have in the center of that, you're going to have very
wait, but
like very low pressure,
so this
but
is low pressure.
around that you're going to have high pressure.
Yeah, but you have to imagine this is in space, so there's no gravity. So
More or less.
so you somehow you need to create pressure. So you need to always refill the pool. And that is dark energy. So you're always refilling the pool in order to create pressure. The pressure here is constant. But here
Oh, I see what you're saying. But still,
because of,
if there's a zone of high velocity there, then there will be like higher pressure.
okay, so let's say there is a pump here that pumps the water out but the pump is at the center, and all the water moves in, and you keep refilling. This is dark, and you keep refilling the pool. There's no gravity. Everything flows out. So because of Gauss's theorem, or this is just Gaussian flow. So you have high velocity flow here, lower velocity flow here, right? Lower and lower and lower velocity flow. This,
More or less.
no, this is
There is always going to be angular momentum.
no, assuming no angular momentum. No. Let's even assume it flows slow, so there's no vortices created. There's no gravity. This is
Yeah, and the
gravitation.
problem.
This is just a pump. There's a pump pulling the water out from the center,
Okay, yeah.
and the water flows in all directions. So according to Gauss, you must have high velocity or high flux. This is the flux here is high.
Same thing.
Flux is defined as volume per time. Defined. So the flux near the pump is great, and the flux away is small. So there is a gradient. So you're getting a gradient of motion, and you end up having pressure here must be high, and pressure here in the center must be low. Otherwise, why would it be moving? So you must have, right? You must have low pressure at the center and high pressure away. So these are gradient lines of the pressure. So if this is the ether.
Okay, but like the things move like that on Earth because of gravity. So this is a little bit.
No, this is gravity.
circular.
No, this is gravity. Gravity is a fluid. We're describing gravity. This is literally gravity. This is dark energy, and this is a mass. A mass is a negative pump. Dark energy refills the pool. Otherwise, you cannot have high pressure. The system fails as soon as you don't have.
Okay, but things flow into low pressure in. Things flow into low pressure mostly because of gravity.
No, there's a pressure
Yes.
differential. No, this works in outer space. We're in outer space. There's no gravity. This is outer space. There's no gravity.
Work in outer space. No, outer space is whatever. Like things just go in their own directions.
No, we're in outer space in an empty universe. There's a box filled with water. You refill the water and you empty the water, and you can even recycle it. I don't believe that this is what happens in our universe, but you can believe it. It could be theoretically true that there is some sort of recycling of the ether through mass and dark energy. It could be, I don't know. Even
Probably be through black holes, if anything.
I don't think so. I looked into black holes. No, there's nothing special about black holes. I don't think so.
Yeah, then you should explain black holes and your theory.
I did.
That was later.
Okay. Yeah, but I explained it many times. There's many videos where I explained it.
I haven't checked that.
Oh, it's very simple. There's nothing weird about it. Einstein got it completely wrong, and Penrose got it completely wrong. Penrose is I don't like Penrose at all. So it's all nonsense, and the singularity is nonsense.
Yeah, the singularity is weird. Like
It's not weird. It's just nonsense. You can't have anything weird. This universe doesn't. This universe is either mechanical or you can go back to sleep. So if you think this universe is weird, you're not. We're not talking about the same universe.
Yeah, and we have no chance of understanding it then.
Right.
If it was weird.
Right. So that I'm not interested in a weird universe. Anytime you end up with a weird universe, I check out of the discussion. I don't care about that. Obviously, it's not scientific. A weird universe is not a scientific universe. Anyway, so you have a gradient, and the way that it works is such that in the direction of the gradient, you have some effect. You have drag, but tangential to the gradient, there's no drag. And that's how you get an orbit. You only have drag in the direction of a gradient. There's gradient.
Yeah, but we still have the problem of the drag. The drag, you know, it's like we're not really figuring out the mechanics of this that well.
Okay, I mean,
Has to be a little bit different from that.
okay, but we're getting there slowly. Okay, I'm not saying it's completely resolved, but what you see right away is in the direction of the drag, in the direction of the gradient, you have a gradient force. In the direction tangential, there's no force. Okay, so the gradient is the force. The gradient, just like when you have buoyancy, the gradient in the pressure, there's lower pressure here and high pressure here. So there's net force upwards. There's no force sideways. I mean, the force sideways are balancing out. So the force sideways is balanced out, but the force here is...
No, there is acceleration, so there is...
It's force. Of course, there's F equals ma with buoyancy, and there's F equals ma with gravity for the same reason. It's the gradient of the pressure.
Yeah, but buoyancy is because like heavier particles in general, or water is heavier than, has more density.
It's not. No. That's not true. You don't need higher density.
Yeah.
No, you assume water. Like I studied fluid mechanics. No, you don't need to assume water. You assume water has a constant density. The water has constant density. It's just that the pressure is higher, and the pressure is reversed. The pressure here is lower, and the pressure here. With gravity is the opposite. With gravity, the pressure here is low, and the pressure here is low.
Yeah, but that's due to gravity. Like that's why it works like that.
Right, but it's the gradient. It's the net force is. Why is there a force on the apple to go this way? The force is by a gradient. It's because there's pressure of the what do you call it? The ether creates pressure, and there's a pressure differential. There's just a pressure differential on the body. That's it, and that's the solution. Done. It's just a
pressure. Less. I mean, you still have the problem that if the ether puts pressure on the body, then when you move in the I mean, it could work, because when you move in the other direction, there would be no problem if the ether only puts pressure on one direction.
The net force sideways is 0, so there's no inertia, but the net force going downwards is not balanced, so you have an acceleration. And that's it, and that's the explanation. So it's just a gradient, exactly like buoyancy. It's a liquid. So you have a mechanical explanation. Done.
Yeah, that's sort of works, but I see how something like this could work. And it's like I'm just need to think a little bit about what the mechanics of something like this would be, because you have something going down, and so there's pressure there, so it doesn't pressure you sideways, but it can pressure you to move down.
Sideways, it's balanced. The ether pressure is balanced. You really have to believe ether is a liquid. If you believe ether is a liquid with pressure differentials, everything works out perfectly. It always ends up being a very rigid liquid.
All that rigid liquid.
But there's no energy loss. For some reason, there's no energy loss in during the interaction. Because
when you move into this when you move with this liquid,
look,
you just push the liquid without suffering any.
No, you're not right. Because there's no heat. It doesn't heat up. It's totally cold.
So there's no drag.
Well, there's no energy loss.
Just simply move with it.
There's no energy loss. There's no heat. If there is no heat, there's no energy loss.
One possibility. Because you just move with it. So there's no heat, there's no. We know that for a fact. The question is, We know for a fact that there is no drag on
Exactly.
the other
But
direction.
we also know there's no
in the
heat.
perpendicular direction of movement.
We also
Of
know
flow.
look, right now it's
I
going
know
through
that
me at 10,000 meters per second, but I'm not experiencing any heat.
it's not like, again, it's not exactly drag. It's like when you move up, you tend to go down, not because
There's
of
no
the drag,
problem. There's no
but
problem
because
with drag.
you
There's
just
no
go down.
listen.
You just slow down again.
There's no problem with drag.
Basically.
The problem with
Yeah.
buoyancy, why it slows you down, is because of heat loss. Because you get these vortices as you go up. You're getting vortices.
Yeah.
So there's energy loss. If you don't have energy loss, there is no issue. You would accelerate upwards
Yeah,
faster and
I see.
faster. So all you need to say is there's no energy loss because there's no vortices. For some reason, no vortices are created, and but also you flow through it very elegantly because you are. I think you're just a wave. You're waving through it. That's my intuition. Why it's
Yeah, like the only thing that the only way that this works really is if you're somehow part of it.
right. You are
That's what I'm thinking about.
exactly. You are it. You
If you're
are
somehow part of it,
no,
then it would work.
you. It's like a
But
wave
if
in
you're
the
not part of it, you just go against it. You just bump into it. You have to be part of it.
exactly.
Okay. That's interesting.
Because we are all waving in the ether. We are ether waves. We are ether.
Yeah, we have to be the same material as it. Yes.
Why?
No, we have to be like either behaving in different ways.
Why do we have to be
No.
of the same material? What's your explanation?
Yeah, we have to be the same as
Why?
it. Like, we have to just be either doing different things.
Why?
Yeah, because otherwise we would be stopped by it. We'd bump into it.
Exactly. So we have to be ether waves.
In a way, yes. Now I can start to agree with that.
So we're ether waves.
Oh, interesting.
I mean,
Let's go to your black hole, if it's simple.
To my what?
I'll think about this further. Yeah, to your black hole, to your theory of black holes, if you want.
My theory of black hole is very simple. It's like I came up with it like even before ether, but it works perfectly with ether. So so let's create a black hole. So in order to understand a black hole, everybody makes a mistake. They all start from a black hole. They try to understand a black hole once it's created. That's very difficult. I don't know how to do that. It's much easier to start before a black hole and create a black hole through a thought experiment. So here is a star, a normal star, and let's give it a binary. It's a binary system, two stars, like similar to the sun. However, this is number one, this is number two. Number one is going to slowly eat the gases from number two. So number one is becoming heavier and heavier. Okay. The highest pressure, let's talk about number one. The highest pressure in a star, okay, so the pressure at the surface is, can you guess how much it is?
Pressure at the surface?
Yes.
Of the star. I mean,
yes.
There's no, if there's no matter, there's no pressure.
Exactly. Pressure is zero. Where is the highest pressure in a star?
At the center.
Exactly. At the center is the highest pressure. So this is P max. Okay. So you can imagine that there is a particle at the center of the star. That particle, you could say, is a proton. But as we're adding more and more layers to the star, there's more and more pressure on this proton. There is a proton, right? You have to imagine there's a proton at the center of planet Earth. There's a proton at the center of the sun. So there's, okay, so this pressure keeps growing and growing and growing. Now, as the pressure grows, this star will become a neutron star, right? At one point, because of degeneracy pressure, it's going to lose the electron and it's going to become a neutron, or it's going to, I don't know, whatever. A proton
It's
decays.
gonna gain an
It's going to
electron.
gain an electron? Good, okay. That's what I was.
For the proton to become a neutron, just to
So it becomes a neutron. So the star becomes a neutron star. So here's the now it's a neutron star. Now we
But
can
basically, what happens with the neutron stars is that like it's like hydrogen that you have like one proton and one electron in hydrogen, and then they are forced together.
That's good.
And,
It's not
yeah,
critical.
they become a neutron
Okay.
basically.
Anyway, so let's talk about the neutron.
Just imagine instead of a proton, you have an hydrogen.
Yeah.
Okay.
It's just a neutron. There is a neutron at the center. At the center of the star, there is a neutron. Here's the neutron. And there is pressure that keeps building on the neutron. Let's take this neutron and let's talk about the pressure. So this neutron is experiencing pressure. So because of the pressure, it takes up less space. So it shrinks under pressure. It keeps shrinking and shrinking under, it's taking up less and less space because of pressure. And the pressure keeps building up more and more. Now, this is force over distance. So this is energy. So we're investing energy into this neutron. Okay, assuming E equals mc squared, that means this neutron is gaining mass. It keeps gaining mass. Now, because ether flows into massive objects, so you're just getting more and more, the flow of ether speeds up. That's the nature of ether. The heavier it is, the faster the flow. How do we know this is true? This comes out of the equations that I developed. Let me get the equation. This goes back to what I showed you before, but I'll just give you we can go through the derivation. I'll just give you the velocity field equation. So the velocity field equation from ma equals gmm over r squared. If you develop the equations, you get v squared is equal to 2gm over r, or the square root if you want to get rid of this. Okay, so the velocity as a function of the radius, this is the velocity as a function of the radius. So the greater the mass, if you keep at the same radius, the greater the velocity of the ether. This is the ether velocity. We can go later. Do you understand this equation? Do you understand what it is?
Yeah, I understand.
Okay. Obviously, if you set v to be the speed of light, then r becomes the Schwarzschild radius. If you want to do that. Anyway, and you can reverse v, put v here and r over here, and you can get the Schwarzschild radius. Okay. From any mass. Anyway, but the point is that we're looking at this neutron. So this neutron, its mass keeps increasing, and therefore, let's forget about C and S. For any radius, the radius keeps shrinking. You could say that the radius keeps shrinking, which means if this is smaller and smaller, meaning this keeps growing. So m goes up, r goes down, therefore v goes up and up. The velocity at the border of the definition of the neutron keeps going up and up, meaning ether is flowing faster and faster and faster. At one point, the ether will flow in at the speed of light. When the ether flows in at the speed of light, light flowing out is stuck. And at that point, it's a black hole. Now, what's inside a black hole? It's just a neutron.
Yeah, makes sense.
There's just a neutron that's it. It's just a neutron.
Or a few.
What?
Or a few.
What is RFU?
Or a few neutrons.
Well, No, no, only one.
Just be one?
Only one, because only one neutron experienced
Oh, okay.
went through this. Now, okay, so let's
Yeah.
go.
And
However,
that was the first one that went
no,
through
no,
this.
no. So the next step. This is just okay. So as soon as this happens, I mean, s- before this happens, the speed of space here, the speed of ether keeps growing and growing, and basically, I mean, what does it mean for the speed of for this area to be at the speed of light? It's a little bit confusing, but basically what happens is if you were here, if you're here, then when you look this way, when you look out, there's infinite distance. If you're able to stand here, you're seeing infinite distance, because as far as the eye can see, there's nothing.
You see no distance, kind of.
Um. Anyway, we'll come back to
Like
this.
you can't see anything because like light is
No,
not
no, no, no,
moving.
no. Wait a minute. No, you're
Oh no! Light is just going all
yeah.
in.
You can see the rest of the universe. You can see the rest of the universe. Okay, but we'll come back to thinking about this is the event. This is the event horizon of a neutron. But this will never be more than one neutron, because think of the neutron right next to it. So the neutron
I'll
right
just
next
get
to
back
it,
to that.
what is so all this time it was applying pressure. Um
Oh, all this time it was applying pressure on that one, and then it probably somehow merged with that. We don't really know.
no.
I mean, we don't know particle physics that well.
No, no, no,
To
no, 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 you
really
don't need to.
understand.
No, no, no. So basically, as soon as there is an event horizon here, space is moving, space is flowing in faster than light. Um, let me think. Let me think what happens.
Faster than light would be create like a sonic boom of some sort.
What?
It create kind of like a sonic boom.
No, no, no. No information can go outwards. So space is
Yeah,
flowing
but
in faster and faster. Light cannot come out. Mm, so this neutron, so all these neutrons that until now were pressing against, right? This neutron has the entire neutron star pressing against it, and it was relying on this guy. But now there's a problem now.
I think that's basically just merge. Well,
It's not. Yeah, I mean, we can just say it merged, but um, mm, let me think. Space is flowing in faster and faster and faster. I think that, I mean, we have to think what is a neutron. So a neutron really is, after all, there's 3 quarks and 3 gluons. This is so infuriating. Every time I select a different color, it doesn't change the color. There's 3 gluons. That is a neutron. And what's going on is it doesn't have a membrane surrounding it. This is just imaginary. These things are jumping around. Just reset. Oh my god.
Some disconnecting happening.
It's a bug.
Yeah.
So anyway, these things are moving around, but I think that what happened is that the gluon has shrunk. There's an immense force on the gluon.
Yeah, like the forces that would generally keep that together are basically
Right. So
also
the energy is in the gluon. Now the gluon doesn't have any
Yeah.
mass, but it has energy. So energy is equivalent to mass.
grow into a different state.
Anyway, I think space. I mean,
Like that force would have to be destroyed and have to be released in some way.
no, but ether is flowing. Like ether is flowing. By the way, from here outwards, but there's no ether here. There's no ether here, so it can't flow. Ether is flowing inwards faster than light. By the way, ether doesn't care about flowing. Ether doesn't have an issue flowing faster than light. We know that ether through entanglement can react at instant speeds.
Can air flow faster than the speed of sound in the earth?
What?
Can air flow faster than the speed of sound in air?
Air right now is moving much faster than the speed of sound around you. Every molecule.
Yeah, but that's different.
Every molecule of air is moving at 2,000 meters per second.
Yes, molecules. Yes.
Right. So the speed of the ether could grow much faster than the speed of light. It's not there's no limit on this flow. It can grow to infinite speed. There's no limit on this. It keeps getting destroyed. Somehow, what we need to end up with is
but you get shockwave. But I mean, it can, but you get shockwave.
No. I don't think so. I don't think there's
because it's like you're constantly trying to compress the medium more than it can be compressed.
No, I don't think there's a limit. No, there's no shockwave. I
you get something like shockwave in these conditions.
No. I created this black hole in a thought experiment slowly in order to avoid a shockwave. It's possible to create a black hole with a shockwave. That's how it usually works. It works with a shockwave, but I don't like that thought experiment. I don't like shockwaves. I'm trying to create it slowly I'm trying to create a black hole slowly. So
but if the ether moves to the speed over the speed of propagation in the ether, over the maximum speed of propagation, then you'd create sort of a shockwave.
No. So
yes, that's kind of how propagation of waves work.
No, because we know that through entanglement it's possible for these bubbles to pop instantaneously. We know that happens, as far as I know, but it doesn't matter. The ether can certainly flow faster than the speed of propagation. The speed of propagation is just, the interaction between the particles that make up the ether. But the ether itself can flow at any speed. It doesn't. There's no limitation on the speed. I mean, I don't think the ether doesn't have a medium. The ether is the medium. So nothing limits the speed of the ether. So the ether can reach faster than light speed, no problem. Anyway, but this is now a black.
More or less, if it's not flowing into more ether, then it can.
No, the ether, when it impacts a material, it disappears. It self-destructs. It destructs. It disappears.
Okay, so
there's no issue.
I mean, I don't think that's 100% clear.
No,
but
I don't see an issue with that.
Yeah, I'm still doubting that.
But you see that matter has existed in the universe for billions of years and has not gained
Yeah.
mass. Like protons didn't become heavier through the eons. Protons weigh the same now as they always did, as far as we know. And the
As
Earth,
far as we know.
but the Earth right now is gaining ether, but it's not gaining mass. You're gaining ether is flowing into you, but you're not gaining mass. Ether has a mass, but when it interacts with mass, it disappears. Just like it appears with dark energy, it disappears. This is like a negative pump. It's being pumped out of the universe somehow. I don't know. Um,
Yeah, it's weird. We still haven't figured that out.
no,
Until we figure that out,
I agree. I know, but what I wanted to say is, as far as the neutron that's being pressed again, right? There is a gradient here. So this neutron, there's low pressure here and high pressure here. So there's a net force on this neutron to move in. But right now, as far as this neutron is concerned, the purple neutron, there's nothing pushing against. There cannot be any pushing outwards. There's no pushing outwards. So there's nothing holding up this neutron. There's nothing holding it up, so it moves in. But
in a way, yeah.
But as it moves
That keeps
in,
happening.
as soon as it moves in, it hits.
I mean, there's the other neutron stopping it, but yeah. Think, are you connected?
Yes,
or
yes, yes.
not?
I'm here. I'm here. I'm just thinking. So, can you hear me?
Yes.
Anyway, it could be that the pressure keeps right. I mean, right now, there's nothing pushing against. Until now, this guy kept bumping against this guy. They were bumping. I mean, that is the pressure. They were bumping against. But at this point, oh, this quark cannot move out anymore. Right. So it's confined. So these quarks now become confined and they can no longer bump against these quarks.
They can?
They cannot, because the inner ones cannot exit. They can move. So let's imagine that this quark can.
I mean, they could couple with the other quarks.
What?
They could start coupling with the other quarks.
No. No,
Yeah,
they can't, because until now, this quark was able to move around and bump against this quark. But now, because the speed of ether here is faster than light, then the inner quark has now become confined. The inner quarks have become confined and they cannot move as freely as before. As soon as they move to here, out close to where the speed of ether is faster than light, they're forced back in. So it's just confined into a smaller and smaller space. So this guy moves in closer and closer.
Mm-hmm. Okay, yeah.
And don't forget that this guy's mass keeps going up and his radius keeps going down. He's experiencing the same pressure. So the velocity here keeps growing.
Yeah.
So they're going to be both with the same problem, and this is going to repeat. So this is like a contagion. It's like a contagion. It becomes confined by ether flowing in too fast, faster than light. So it's confined, and the other neutrons are going to fall in as well. So When you fall into,
Mm.
yeah. So at the center of a black hole is just compressed, just very compressed matter, nothing more. Just very compressed quarks, just very compressed neutrons. That's all that there is in there. This is a black hole, and if you fall into this, you're going to experience the same problem.
Mm.
It's not a corridor to another
Okay,
universe.
I mean, I see there's a bit of work to do, but I see the general idea.
It's just a mechanical
I mean,
explanation. Like
the
Einstein,
general, yeah,
there's no
the
worm,
general idea makes sense.
there's
That's
no there's no
that's a
magical
good way of it.
wormhole. There's no magical white hole. There's no nonsense with Penrose and his multiple universes. None of that.
But
That's
like another thing that could be interesting to think about here, like, so if all that Hitler is flowing, that
what?
would at some point, that Hitler like get together and eject in some way?
No,
Because there's some
nothing.
phenomena like that in
Nothing
black
can.
holes, like where they
No,
where they have been observed to eject matter sometimes,
no,
eject hydrogen mainly.
no.
Like for example, some of these neutrons who are like in very high pressure get released and
What?
then
I
they
don't
become
understand.
hydrogen.
Wait, what are you saying?
Yeah, like those neutrons around that are in high pressure sometimes get like ejected and released.
How?
And
This is this ether here is flowing fast.
asymmetries,
What?
asymmetries.
Asymmetry?
Yeah, like sometimes could cause like some ejection of matter and decompression.
You can't. You can't.
How it happens? Let me like
You
let me
have
like look for that.
ether here is moving faster than light. These
Yeah,
guys,
where-
these guys, they cannot move faster than light because
yeah, but that's like
these are waves in the
something
ether.
called astrophysical jet.
No, no. These are waves. These are waves. They need to wave out. They can't. These waves can never move faster than light. So they're perfectly confined. There's absolutely no way out of this thing.
But no, but that's different from what happens.
What do you mean?
Right. Yeah, there's something called astrophysical jets.
No, that's different. Astrophysical jets is outside. That's in the disk, in the whatever disk. That's not. I don't care about that. I don't care about any astro.
Yeah, it's not exactly on the okay, this is more or less like it's not exactly on the center, but that is
Right.
there
This
are some
is
models for this we can do.
this is the black hole. This is the event horizon. Nothing can ever escape the event horizon because these are waves. They cannot wave out beyond the speed of light, beyond the speed of waving. And this is faster than the speed of waving. So there's just no way they're going to get out. But the point is, there's no magical universe. There's no magic. There's no wormhole. There's no white hole. There's no nonsense. What Einstein thought with his wormhole and his Einstein-Rosen bridge, these are mathematical artifacts caused by division by zero.
Yeah, I know that.
So as long as you understand that Newtonian, this equation doesn't apply for. I mean, it applies for r equals zero, but when you get to the scale of the neutron, you have to start thinking about what it looks like. So there's no division by zero here. You cannot. You can be here. If you're here, there's no problem to be here. You don't get infinities anywhere. There's no infinities. You can get faster than light motion. That's not a violation of any law of nature. Ether can flow faster than light. Ether is not bound by the faster than light, right? The waves in the ether cannot move faster than the speed of propagation.
Yeah, as long as it doesn't move into itself, that's the issue.
What do you mean? No, but the only thing you could have, so if you have an entangled wave, so if the wave collapses here, it will cause this guy to not collapse. So you can have information because entanglement can violate the speed because there's no waving going on. This is allowed. There's no there's no problem with entanglement. So you're allowed to take an electromagnetic wave and collapse it here and therefore not collapse it here. And the information of the wave collapse is allowed to escape because that is instantaneous. That for some reason doesn't care about the propagation of information because there is no information propagated. There's no information propagated in the collapse of the wave, in the entanglement. Something like that. That I mean, everyone agrees and experiments agree. I never looked into. I haven't. I've never seen these experiments, so I can.
Yeah, you should look into that. You should look into the chain of experiments
Sure,
about
sure.
entanglement.
But the point is,
Like one of them is that experiment I sent you yesterday.
yeah. Look, but the point is, there's no problem to be at the center, at the very center of this black hole. There's nothing special about it. There's nothing special. This is just,
Okay. No, but I see your theory. Yes, I see. Still in development, but yeah, it's a good idea in general.
it's very
Like
mechanical.
it has to be something like that.
Yeah, it's mechanical. There's no issues.
Yeah, there's no magic.
There's
That's
no
a good
magic.
thing.
There's no magic. Okay, but the point is, the more you throw in matter into this thing, it keeps growing. The Schwarzschild radius keeps growing. There's no point of infinite density. That's nonsense. From this equation, they say that there's a point of infinite density. I don't know how they get to this. I don't understand it. I mean, this
Yeah, there's no
equation.
need for that.
By the way, this
No,
equation.
I mean they get to that in the same way they got. Yesterday we were discussing that with the
No.
with the ultraviolet catastrophe.
I don't know.
It's just mathematics.
I
that
look.
gets you to that. No, it's just mathematics, really.
No.
They reduce the radius to zero, and that's it.
No. I know. I don't know anything about the ultraviolet catastrophe. We didn't look into that. Into this.
Oh, I looked into that afterwards.
Okay, but look, what they're saying is F equals GMM over R squared. They say as R goes to zero, this force goes to infinity. Okay, yeah, but that's because this is an approximation. This is an approximation.
Yeah.
As you talk about R going to zero, you need to consider what it means to be at R equals zero. You need to talk about right? This is not a particle theory. This is a field equation. This is a field equation. This is not a particle theory. As you get close to the size of the particle, close to zero, you need to go back and think, okay, these are the particles. Now what? Where's R? Why do you have any issue? What does it mean at R? At R equals zero, the force is zero. There's no force here because there's no force here. Why should there be any force here? This is complete. It's like it's at the center of something. There's no force here. There's nothing here. There's nothing here. There's nothing special.
I got the idea.
Anyway, yeah, they're lazy. So everyone is lazy.
I mean, it's not so much that it's like it's the idea that you just do the mathematics and you see where the maths gets you to.
Yeah, they get lost.
There's just not a lot of experimentation, and there's not a lot of like thinking mechanically about
Sabine Hossenfelder, she wrote a book, Lost in Math. Do you know this book?
Yeah.
So
I know she wrote a book. Yes, I
never
read the book.
They hate her. They all hate each
Yeah,
other.
I think she's not popular.
She's not popular because she criticizes them. She wants to take their funding away. They keep asking for billions of dollars to build more particle accelerators. She keeps saying that's
Yeah.
nonsense. They should not get any more funding. There's no more particles to be discovered. She's terrific, but her book is genius. Lost in Math. When I first heard of it, I was like, "Wait, what? Like physicists are part of a
Yeah,
cult?"
physicists have, but yeah, you didn't notice that before. Like physicists have been completely lost in math since
Yeah.
since Einstein.
So
And like string theory is like the ultimate thing about that.
So I
Like
don't
it's been
even.
just
I don't.
there's no reason for any
Yeah,
of the of
yeah. I don't. I
just a
have
bunch of
nothing to say.
yeah, just a bunch of mathematical considerations that have no connection to reality.
I don't know anything about string theory, and I honestly,
It's just like the idea is that they imagine that the universe would be made of strings, and then they try to calculate everything based on it. There's
I
no reason for it.
there's no right
Completely pointless.
because we already know that the particles are the waves in the ether. What's the question? What are you trying to answer? I don't even know what they're trying to answer. And by the way, there's no.
They're
So,
not. That's the problem. They're not. It's look. It's not like they're trying to answer anything in specific.
but
It's
by
like
the way,
when you make when you create some kind of cryptocurrency and then you say it could be used like this and like that and like this, and there's no actual problem that
but
you're solving.
also notice that there is
Like,
no quantum. There's no
like,
quantum. I mean, this is quantum gravity. So here's the answer to quantum gravity, and you got it for free. You didn't even pay me.
yeah, I mean this is like good ideas, but they need to be developed a lot
Okay,
more.
do you want to see a
That's the
graviton?
thing. And let's see graviton. Okay.
Okay, so I already did this presentation once. Let's go to the next page. This is going to be the graviton.
Yeah.
There's graviton and there's gravioli. Do you know that joke
Graviton.
from Futurama?
No, I have no idea.
Gravitons and the graviolis. Did you ever watch Futurama?
No, no, I don't watch almost anything like
Yeah,
fiction.
but that's like I'm old, so I loved Futurama. It was so funny. I watched everything. I'm an expert in Futurama. Futurama is like the show before Rick and Morty. Anyway,
I know what the show is. Yeah.
okay. So what is a graviton? So a graviton. So it's very similar. It's very similar to what the discussion yesterday with taking the electron. We took an electron and we moved an electron and we created a shock wave in the universe. And the same thing can be said about a neutron, but also about the electron,
Oh, I see where we're going.
but also about the neutron. We can take a neutron and move the neutron, and we're creating a shock wave of what? So here's the test particle neutron. So this is the force of gravity it was feeling before, and this is the force of gravity it's feeling after. So you have these waves propagating throughout the universe. So when you do this, when you right, and the amount of information that you added here is the smallest one. You could basically say it's the energy of a photon. And I think it's the same thing. E equals. I think you can still say E equals H F. The question is, what is the frequency of a neutron? But because of de Broglie, a neutron has a frequency. A neutron is a wave, or maybe it's a quark. It could also be an electron. I don't care. Anyway, so assuming right, the neutron has a certain frequency times h. That's the minimal. So we know the minimal energy that we can invest into the system. So there is a minimal amount of energy that we can invest into the motion of this neutron. So we invested that energy, and now the energy has a shock wave of information through the ether. So here's the shock wave. So every test particle around the universe is experiencing this information. This, right? That they are all. This is the old direction, and as soon as the information wave hits, so this is the new. So they all change. So right. This is a test particle. It doesn't exist. It could be there. It's the field. We're talking about the influence that this shockwave. It's a shockwave of influence of the field, of the update of the field. Anyway, now because this is the minimal, because of Planck, this is the minimal energy that we can invest. That means that any test particle that ends up interacting with this information, that is really moved, that really experiences, that really gets the energy, anyone, it cannot be two because it's the minimal energy. It cannot be two.
You explained that yesterday, but I think we should look into entanglement a bit more.
Anyway, but this is entanglement. So because of entanglement, so only one of them will experience, which means, and that is a graviton. So whoever this guy will experience, if this guy experiences it, that it is experiencing a graviton. That is a graviton. Ta-da! Nobel Prize, please. Nobel Prize. I demand the Nobel Prize.
More. We should have other prize. Should have the Nobel Prize.
The Nobel Prize. Nobel.
No bull. No bull prize.
Anyway,
yes,
it's something like that. Something like that. Because it is gravity, right? This is gravity. We're talking about the gravitational effect. This is a gravitational effect. Neutron to neutron is a gravitational effect. So it's a graviton. Because as the entanglement takes place, and you have, this is the collapse of the gravitational wave. This is a gravitational wave, by the way. This is literally a gravitational wave. And this is the collapse of a gravitational wave into a graviton. This is a gravitational wave. If these were two black holes merging, they would create exactly the same gravitational wave. They would send a shock wave through the universe. But the energy is too big. There's too many gravitons, so it's going to be I don't think you're going to be able to notice anything. But here you actually get one graviton, and you'll be able to see it. I don't know, maybe. I don't know enough about entanglement. I don't know enough about particles and anything. I don't know anything. But maybe if this were done in a cloud chamber, you might see the graviton, and the graviton then will collapse, not collapse, but will, through Feynman diagram, will deteriorate into something else. It will instantaneously show up here somehow by magic, because everybody knows this universe is magical. Anyway, the graviton will show up here and then will collapse. Something like that. Who knows? I don't know. And then you'll find, I don't know, maybe two photons or something. Like they found the Higgs. They found two photons going in a certain angle or something.
Hard to know. It's hard to know.
I mean, I don't know.
It needs a bit more clarity. I think what's clear is that we need some kind of medium for this to happen.
Yeah, I don't know. I don't know how this works.
That's clear. Anyways, you were criticizing a lecture.
I'm what?
You were criticizing a lecture some time ago
I was
when
criticizing
I joined in.
Alexa?
A lecture,
I was criticizing a lecture? What?
yes.
What do you mean criticizing a lecture?
Yeah, before I came in,
Oh!
you were thinking about the lecture.
Okay. So, what do you want? So I didn't. So I only did research today. I didn't write anything. Um, do you want to go and come back later,
Okay.
and we'll talk more, or you had enough for today?
Yeah, it can be that. Yes, we
Okay,
can talk more later or tomorrow. It's
fine.
okay. Yeah, I mean, if you want to talk, you can just say I think I'll be here.
Okay,
Have the computer and the phone.
okay.
I'll
I'm going.
sit.
I see. I have comments in the comment section. I'm going to read some comments. Then
You
I'll
will?
finish.
Let me check the comments too. Okay,
Oh,
yeah, you
okay.
have comments indeed.
So we have
Nicholas Williams.
Nicholas Williams. Differential Planck lengths 1 over curvature equals smaller Planck lengths and smaller speed of light. I don't know.
I don't know what he's referring to.
There is no. I don't.
Specifically.
We don't
What?
believe in. So he thinks. I don't believe in curvature. I think the interpretation of GR with curvature is incorrect. So I don't have curvature in my understanding. I have the flow of ether instead of curvature. So I don't know what you're referring to. 1 over curvature degree equals smaller h circumference, smaller force transfer. I guess he's talking about the black hole. You are in the right place, I'm pretty sure, except for the flow. No, no, the flow. I showed the evolution of the flow from. I didn't show the development of the equation. I need to go. I did it once. I need to go through it again. So maybe I'll do a separate lecture about that. But from Newtonian gravitational and mechanics, I got the field equation for the velocity of the ether. It comes directly out of that, and from that you get Schwarzschild radius, and from that you can understand how a neutron can become a black hole, and that is the flow. Smaller force transfer speed. I don't know what you mean. Planck unit.
No, he has an interesting. He's saying some interesting stuff.
What?
He's saying some interesting stuff. It's good stuff to consider.
Yeah. Okay. So Planck units align in a way as to balance out toroidal jet pressure. No, I don't care about the jet pressures. That's like an artifact of like the external of the black hole. I don't care about that. The gluons propagate across the Planck units. I don't know what he's saying. This holds the structure from collapsing from the high G to G differential. I don't know what you mean. I mean, we showed that you get a collapse. I mean, what do you mean by a collapse? You just get faster than light flow of the ether. That's all that you get, and that's it. And that's a black hole. There's nothing special about it. The gluon is the resistance. No, but what I did want to talk about is the fact that you can have a supermassive black hole. No, but it has a size. See, people think that there is a zero size dot inside the black hole with infinite density or something. No, you don't need that. You have something
Okay,
inside.
so
Hmm?
you know what the gluon is or not?
Yeah. But I'm not talking about the gluon. I'm talking. I just wanted to say something before. People think that there is a dot, a point mass inside the black hole with infinite density. So the thought experiment of Isaac Newton, the GMM over r squared, those m's are point masses. So already there you have a point mass of infinite density. So the infinite density is the very assumption. So you cannot conclude, oh, you have infinite density. No. That is the assumption. It's a simplification of the planet. But when you talk about this, the Earth Sun system, you don't want to deal with balls of densities. You would rather just deal with 2 point masses to simplify the equations. These point masses are of infinite density by definition. That's not the conclusion of the discussion. That is the assumption. It's a mathematical simplification. When you get so inside a black hole, there's no point mass. Inside the black hole, there's exactly what we showed. There's just condensed neutrons. It's black, but it's big. It's not zero size. It's black because of black shift. After red shift, you get black shift. Light cannot escape. Nothing can escape. That's why it looks black. But internally, it's huge. It's very big. There's no reason for it to be of insignificant size. It just needs to be inside. The neutron just needs to be inside its own Schwarzschild radius. Ta-da! There's no magic. So it's completely mechanical. There's no other universes on the other side. There's no white holes. There's no big bangs internally. It's very simple. And if you fall in, it's like falling into a neutron star. That's all. It's just an inconvenience. I mean, but you're not going to fall into. I used to think that it's a separate universe. No, there's no other universe. It's just a neutron star that went the extra step and is inside its own Schwarzschild radius. That's all. Nothing strange happens. Anyway, the gluon is the resistance. Yeah, the gluon is the resistance. Sure. It's not the glue. Okay. The strong force is the glue, and that's created from G minus G. Gluon to gluon. All right. I don't know enough particle physics. I'm sorry. The gluon is like a photon. Yeah. But the Planck units are much denser. I don't know what you mean by the Planck units. Therefore, the speed of light is small. No.
I think this is similar to like Nassim Haramein
I don't know.
conception.
I don't know anything.
Yeah, he's like an independent physicist.
Yeah, I don't know anything about what he says, but the speed of light is always constant. We have a separate proof for that. Unlike Einstein, who postulated it, we actually prove it. The speed of light is constant.
I mean, if the medium changes, the speed of light will change.
No, but the definition of the speed of light is it's a speed of a wave. The definition of
but if the medium changes, that can change.
No, because the definition of speed is defined by a distance over time, but time is defined by a mechanism such as a clock. So it's distance over ticking. So let's say it's 1 unit of distance over 1 tick of a clock. Now with
but if imagine you have that system and the medium becomes different, like
it doesn't matter. It doesn't matter because
really matter.
If the clock depends on the medium, then it's always going to be 1 tick of the clock. So as far as anything is concerned, scientifically, it's the same time, quote unquote. It's the same tick. So the speed of light can never change.
But if you compare to different clocks, one with different mediums, it would change.
Wherever you measure the speed of a wave, that is you're going to be using a clock right there. The speed of light is constant for all moving observers. When they measure, wait, did we lose you?
No.
Oh, hamburger and fries. How are you, Amber? Hey, what's up? We're still doing.
Oh, yeah.
No, it's okay. We're doing fancy schmancy physics like always.
Yeah, I kick ass.
What? You kick ass?
I said that's kick ass.
Oh, definitely. Yeah, we're cutting edge. We're cutting the edges. Anyway, so the speed the speed of light, we prove that the speed of light is constant for all moving observers. So we prove it, unlike Einstein, who postulated it He said, I'm elevating it from a conjecture to a postulate. I don't even know what those words mean, but he never proved it. No one has ever proved it. I scoured the universe. So I'm the first person to offer a proof. It's not even a proof. It's a definitional. It comes out of the very definition of the word speed. Anyway, let's continue. And we still need to write a paper about that. We have a list of papers that we need to write. Anyway,
You guys need a Google Doc thing, like just open to each other.
what?
You could like set up a Google Doc so you guys can work on the same document together.
Yeah,
Yeah.
I need
We can do
collaborators.
that, but we need to figure out this a bit better, because if we write a paper, we'll need to defend all of this.
Look, the paper about proving the speed of light is constant for all moving observers. That is definite. That I mean that's 100% guaranteed proof. There's no question about that. So that paper is first in line to write. Everything else, everything else will come
Yeah.
after. Okay, so let's see. Nicholas says photon is collision between Planck units. I would say that photons don't exist. That what you have is an electromagnetic wave that is created by, let's say, a moving electron. So that creates a three-dimensional spherical propagation of energy. But that energy, it's some energy. When that energy interacts with anything, so the wave collapses and the energy is exchanged. That is what you feel is a photon. A photon never exists except for when you observe the wave. And that is basically the particle wave duality, the way I see it. When the Planck unit is smaller, why do you keep talking about Planck unit? What is it, Planck? We never discussed Planck units. It's smaller. It has a slower transfer speed to the next. I don't know what you're talking about. I guess he's like talking about. I think a neutron is much bigger than a Planck unit. So we're not there. There is universe in the gaps between the Planck units. No, it's because the geometry. It's because of the geometry. There is a diamond shape. So if you trace the reflection low, I don't know what you're talking about. The diamond shape. I think that's the Einstein-Rosen bridge. It's a mathematical artifact. I don't care about it. It's not real. The quark is like a large Planck. Why do you keep saying things about Planck unit? I don't understand what you're talking about. Nicholas Williams, you can join us and tell us what you think, but I have no idea what you're saying. You keep referring to Planck units. I never discussed Planck units. The Planck units are super small there. We might be able to get this Planck length relative to light speed outside relative to light speed inside. I don't know what you're saying. I noticed that everyone in that community hates each other. She's awesome. She's not awesome. She's better than the rest. She's far from awesome. She's still terrible. They definitely are. Good points. She's terrible because, well, at least for one, one problem I have with her is that she is a global warming hysteric. So I don't like people who believe in global warming. That's ridiculous. There's no evidence for global warming. It's nonsense. Anyway, 1 over Planck velocity curvature. I don't know what you're talking about, man. I honestly have no idea. A gravitation isn't an oscillation. No, a graviton isn't an oscillation. No, a graviton is the collapse of a gravity wave by definition. So that's all I showed. I just showed the collapse of a gravity wave. So a gravity wave, like all waves, when it interacts, when it endows its energy into anything, certainly if it only has enough energy to interact with just one particle because of Planck's constant, because of minimal energy, then it has to collapse into just one interaction. That interaction, that energy is a graviton, just by definition. You don't see a. I don't think you're going to see a particle. I don't think you ever see particles. I don't think you see particles. I don't know. Maybe you do. Anyway. Yes, it is. It is the collapse of the oscillation. It's the collapse of the wave. Or gravity isn't an oscillation. Yes, gravity travels in waves. So gravity travels, and any information travels through the ether as waves. That, I mean, that's except for entanglement. I mean, the collapse of the wave doesn't travel in a wave, obviously. Oh, that's the answer, by the way. So the collapse of the wave doesn't travel as a wave. It's instantaneous. But the wave itself travels at the speed of propagation through the medium, namely the speed of light. If the gluon over distance between Planck units, mass, force, gravity, I don't know what you're saying. The strong force is gravity. No, the strong force is the strong force between quarks and gluons. That's not.
No, you can unify strong force with gravity. Apparently, there's some theories of that.
No, gravity is the flow of the ether. You don't know. Gravity is.
Yes, but you can unify the strong force with that as well.
No, because an electron also has mass. So any interaction with the Higgs creates mass. And any interaction between the ether and a mass destroys the ether and creates a vacuum and creates the flow of the ether into this vacuum, and anything that gets in the way gets sucked in and feels what we call gravity. Higher curvature degrees in the Planck field. Okay, you're writing a lot, Nicholas. I can't go on forever. I gotta end this stream. G, gravitational power of I don't know. Look, I don't know what you mean by these Planck things. G is equal to gravitation power of Planck. I don't know. I have no idea. It's a pushing for. I have no idea what you're saying. Okay, so we read the comments. I'm going to end here, and then I'll come back.
Yeah, we'll come back.
Yeah.
Today or tomorrow we can discuss again.
Okay. Yeah, but I'm gonna come back and keep. I need to do more research. All right, man. I'll see you later.
See ya.
Bye.
Bye bye.
Bye bye.